Hey everybody. Today we're going to talk about dimensional analysis. Who cares about dimensional analysis? We do. We're going to learn how to use dimensional analysis by taking a look at a real-life problem. In 1983, there was an Air Canada plane that crashed because it ran out of fuel. Why did it run out of fuel? Somebody didn't convert the units properly. This is why we want to learn dimensional analysis. Take a look at this video to get some background information on the flight. Okay, so maybe in real life we actually do need this thing called dimensional analysis. You'll actually notice online it can be called the factor label method as well. What does it mean? Well, dimensional analysis means to examine the measurement of an object. So things that we can measure. It doesn't have to be a physical object per se. It could be time as well, and distance, not necessarily a tangible object like an apple or a book. It could be miles per hour or converting that to meters per second. So it's anything that can be measured, okay? So analysis, by definition, is the detailed examination of elements or structure of something, typically a basis for the discussion or interpretation. You analyze something, okay? Dimensions, those are things that you can measure of an object, okay? You can measure its length or width or height. Any kind of a quantifiable value that you can make on an object would be part of the dimension. So in this particular case study of Flight 143, what's the physical object? It's the fuel. The fuel was the problem. The fuel attendant, not flight attendant, sorry, the fuel attendant miscalculated and calculated from liters to pounds instead of liters to kilograms. And in Canada, that's a big deal. They use the metric system. So it's a big problem. Let's see how big the problem really was and why this plane ran out of gas mid-flight. Okay, so the problem is the fuel measurement for Flight 143, again, should have been from a volume measurement of liters to a mass measurement of kilograms. This would allow us to keep the units both in the metric system. While we do have abilities to convert between the metric and our English system, the fuel attendant should not have gone to pounds because Canada doesn't use pounds. They use kilograms. So what happened? The fuel attendant made a gross error, okay? What's our job? Your job is to determine how much fuel in kilograms was actually put into the plane using dimensional analysis. Recall, the fuel attendant, I keep saying that, I know, I'm sorry. The fuel attendant was supposed to put 22,300 kilograms of fuel into the plane, but instead the attendant put 22,300 pounds of fuel into the plane. Let's see what the difference is. So again, we're taking a look at our dimensional analysis problem. The Boeing 767 aircraft, Flight 143, needed 22,300 kilograms of fuel, but was filled with 22,300 pounds of fuel. If you don't think that that's a big deal, we're about to find out it is. So our task is to use dimensional analysis to find the amount of fuel that was actually put into the jet from the fuel truck. There's 5 steps that we're going to follow, and you can add these into your notes. The first step is you have to determine the given. Well, our given value, we know to be true, is that the plane was filled with 22,300 pounds of fuel. Okay, so add that into your notes. Step 2, determine the target. Where do we want to go? We need to get to kilograms of fuel. So make sure you write that down in your notes. Our third step is to determine what we need to bridge the gap between what we're given and what we need to get to. In this case, we need to go from pounds to kilograms. And it just so happens that there are 2.2 pounds for every kilogram. We will look at equalities in more detail later. You know a bunch of equalities. You know that there are 60 seconds in a minute, 24 hours in a day, 60 minutes in an hour. You know that there are 12 inches in a foot. Okay, so you know these kinds of conversions already. The metric system is not as well known to us. This particular equality bridges the gap from pounds, our English measurement of mass, to kilograms. Anyways, make sure you add step 3 into your notes, and let's move on to step 4. We have to build a conversion factor. When we do this, we have to think about what we were given again. We were given 22,300 pounds. So we have to divide out the pounds, okay? So we're going to draw a little chart here. And we're going to divide out the pounds. So we're going to put pounds on the bottom because whatever you want to get rid of, the only way in multiplication and division to get rid of it is to cancel it out by division, right? So we're going to put 2.2 pounds down here. We also know that we want to get to kilograms. So we're going to put kilograms on top because the unit we want to get to goes on top. Okay? So we line this up in such a way then that when we divide, our pounds will cancel and we're left with kilograms, which is what we're looking for. That's our target. Go ahead and add this into your notes. Step 5 is to actually do the calculation. So after you're done with your setup here, you have to take 22,300 and divide it by 2.2. When you do this, you get an answer of 10,136 kilograms of fuel. They didn't even receive half the fuel that they needed. They needed 22,300 kilograms, but they were only given 10,136 kilograms. Bear in mind, I did not keep proper sig figs on purpose. I rounded to the nearest whole value because that's what a plane would do. However, these little minute issues with significant figures from first semester, they're going to come back and we have to remember those rules, okay? But for this particular problem, I kept it to the whole number of kilograms because that's what a fuel attendant would do, okay? So this is a big problem. One last question of the day. How much more fuel did this poor plane, Flight 143, need in kilograms? Well, it required 22,300 kilograms, and it was fueled with 10,136 kilograms. If we subtract them, right, we find out that we needed, or they needed, 12,164 kilograms more. Yikes. That's pretty terrible.